So I'm a scientist,
Yes.
and I don't want to be made redundant. So
Me
my
neither.
question with AI, I mean, one of the big questions at the moment is model collapse, because models are being trained on material that AI is already generating. How are we going to avoid this? Because obviously science has a feedback mechanism where we publish and then somebody else reproduces our work, and then they find out we were full of shit. And they publish, and it goes around. So how are you going to avoid that?
Well, so, if you take a look at a particular model, yes. I mean, just like humans, okay? Humans were trained on past work, right? As scientists, we go to grad school, read a lot of papers, and then we get insights, but we just don't get insights alone. We get insights as a part of our scientific process. So the crux of the AI scientist idea is not so much to use AI as part of the process where you have some trained AI and may generate results based on your past record. AI itself will become curious as human beings are, and actually drive the entire scientific process just like humans do. And in fact, it's not just single human. As scientists, we have a whole community of human scientists. And we have the papers are there for us to communicate new ideas and new findings. And same with AI. So we have a community of AI agents who have tools at their arsenal. In order to make new discoveries, yes, they have to run new experiments. Yes, they have to do new simulations, physics based on physical experiments or physical simulations, not AI, not just surrogates, but in some cases, real first principle driven simulations. Sometimes combined with surrogate, but nonetheless, they need to make new discoveries. So this whole process, which if you remove all the mechanical elements of AI, is synonymous to what humans do in the first place. So the whole idea of AI scientists is not just to replace a part of your work, of, let's say, doing idea generation or doing some background research, but to replace the entire process, which mimics or even go beyond what the humans are doing.
So the way science actually works is it doesn't work in a sort of nice linear way and we look at everything that's going on. What happens is something doesn't work. This actually goes back to a comment earlier about publication of failure. And I know from when I did my own PhD, there was a whole section that just didn't work.
Yeah.
And my supervisor said, write it up anyway, because you spent a year working on this, write it up, didn't work, doesn't matter, but write it up. So if we're not publishing those failures, how is the AI going to learn from the failures that we're not publishing? And how is it going to be able to spot those mistakes in its own work?
Well, I'll counter that argument by saying why we don't publish failed work, because the reason we're not incentivized to, right? Because we have our, science has developed a system where we get our raises and promotions and such, and by successes and mostly not by failures. And that's exactly the point of Manish. We need to make the failures be credible, but of course, there's a long way. Now, AI agents of course, it all depends on how you design a system, but we can design the entire system like this with the incentive that are less human to record the failures as well. So I think AI scientists have an advantage because they don't need, of course there still needs to be some trust system. There still probably will, because we need to do resource allocation, because some of the studies I've done has shown that what will be the biggest impediment to realizing this idea is actually the validation part, not so much running the AI part, but validating the results, doing the experiments, doing simulation. That's going to be the big resource. big resource consumer. So we do have to, like we do now, there still has to be some merit-based system. But again, AIs don't have to earn money, well, unless we tell them to. So it could be that we may have having at least, if not replacing humans, but at least some of these being driven by AI, we have a much bigger chance of being able to record failures.
Patricia.
Yeah.
My question is regarding creativity. So part of the scientific discovery is here. Part of the scientific discovery involves that little genius part, that thing that it never occurs to anyone and suddenly someone thinks about it and a couple of people are thinking about it collectively. So, and that worries me because it's very simple and silly example, but to come to multi-core world, we have to write a justification. So I wrote my very human justification, 3 lines, and then my admin returned it and said no. You have to write something more complex. So I was like, I don't have time for this. So I asked ChatGPT, write me something. I just tell him, I'm going to multi-core world, write me a justification. And ChatGPT gave me an entire page why me personally should go to multi-core world, and I submitted that to my admin. And then my admin sent it back saying, yeah, this is good, but also I want to share with you what other person wrote. And it was exactly the same thing. I don't know if it was generated with the same AI agent. But so aren't we going to end up with exactly the same answer, and then the discovery part, the geniusy part is going to go away because of AI?
There is only one reason to come to multi-core world.
Yeah, so right now, humans have evolved through this natural evolution, and we have a very somewhat, one could call inefficient because it takes, at least 20 plus years to generate anyone who's useful to do any intelligent work. On the other hand, we have built a societal system where we can produce billions of these minds. Right? Maybe not everybody's doing what I call intelligent work, but we have billions of people. And we have built a society where there's, through evolution, and through all this societal structures that we train these brains. To some extent, somewhat monolithically during the early educations, but of course we diverge as we go and pursue interests. So, but like I said, right now the AIs are fairly monolithic because of 2 reasons. One is we're all using maybe a very handful of these commercial models, right? Either public or private, but also, this is what LeCun points out. It still doesn't have the proper notion of a physical world, which may affect the individual and the individual situations. But there's no, but on the other hand, there's really no impediment to saying we can have lots of these agents, and they can be custom trained to some extent. You can have a baseline, but they can be custom trained. Fine tuning is easy, and the custom trained, according to expertise, we all know that now these agents are being customized to various extents, and then they'll behave differently, and they'll have a physical, and they'll be situated in different physical models. And moreover, the way we attain these creativity is not through our individuals, right? Because our interactions with the outside physical world, but also interacting with other humans, right? If we don't do that, the only scholarly thing we can do is probably, let's call your job, will be a philosopher, right? He can think without being disturbed by anyone else, and in a secluded environment. Every other science, we have interactions with the physical world. We have interaction with other scientists or the communities. We have interactions with people with slightly different backgrounds. And that's how, so as a community, we develop these creativity and uniqueness. And that's what exactly we're envisioning with a model like this, or a model like this, where these will not be monolithic. The reason we have this community of agents is because just like we have community of scientists, we want divergent sets of communities of scientific agents that will communicate, have their own expertise, and as a mass, will develop something that you can call creativity.
Ilkay?
I have a related question. What is not included in the AI scientist, and what is the role of the human being?
Well, so again, I painted both a bright future and also dystopian future. For example, if you look at the Mold Book, a lot of people say it's the Mold Book. If you look at the chat, what's the generated Mold Book? It's really fascinating. But a lot of people say not all these chats are actually agent generated. There's certainly some people suspect that there are some human elements in there. People posting, faking themselves as agents and posting something unique, and then the agent starts to respond. So that's sort of a very fragmentary, but this is what he's saying. Well, human intervention still helps to move the community along, even though it's the agents who are mainly interacting. Humans still may have a big role in coming up with new observation, in the future, maybe not. But at least for some foreseeable future, human beings will still have some advantage, have some unique advantage. So this will likely, these agents themselves, as much as we like to automate, probably will have, some of these will be humans. But the future will be like humans and agents interacting to realize this vision.
Yeah. Ben?
Yeah. Hello. So good to see this. I've kind of been working in a very similar area for the last few years. It's more of a comment on what you just kind of were talking about. I've always painted it as we're not fully replacing scientists, but we are giving the scientists extremely different tool sets that is going to change the way how scientists are thinking in terms of what they're going about doing. So, for instance, going from the slide rule to the calculator, people can still do math today. Going from no computers to computers, we can do lots of interesting new things that we couldn't do before. I feel like there's going to be a similar shift in the scientific community and how they go about their research with these technologies. And it's going to be interesting to see where, like my kids, if they go into science, how they're going to adapt and come up with new ways of doing science that we currently can't even think about because this hasn't been put into place, but it's moving in this direction, like you said.
Yeah. I mean, well, firstly, yes, there's a upcoming culture shift in the short run. For example, again, if you believe in scaling law, not just applicable to large language models, but to many other scientific models. So this says that the days of taking very small sets of pristine data are over. If you believe in scaling law, and we have several people on our teams that we can actually providing evidence that in many fields, in non-lingual models, that scaling law does apply. And if they apply, the data collection piece of the science will have to be mechanized. You can't just have humans taking this, champion data. You need to totally automate the process and generate a whole bunch of data in order to be able to train these models with emergent behavior. So that alone is changing. This has actually been going on like in areas like genetics, where you have Illumina sequencers, just taking massive amounts of sequences. But this will happen in every domain. Now, so that's sort of a cultural shift. But I feel that, yes, we will make gradual changes, but by setting a very high goal to make ourselves replaceable. So we don't know if that'll be reached, or humans may evolve to some higher being. But by setting a very high goal of replacing humans, then I think we can achieve more than just saying AI is a useful tool. So it's a more deliberate attempt at challenging the whole scientific system, that we try to replace as much as possible. And the ultimate goal is to advance science, right? It's not so much to keep our jobs, but the ultimate goal is to advance science. And that's why I think saying replacing us will be the ultimate goal, will be the grand challenge that we need to set ourselves.
And Dan Stanzione.
Thanks,
Okay,
thanks, Satoshi. I will say I'm not worried about running out of jobs anytime soon. Anybody who's tried to keep one of these loops going. Plenty of human intervention for the long term. But I am sort of not so much about replacing the humans, but the first year or two after the ChatGPT thing, there was a lot of talk about, how much of HPC workloads would get replaced by surrogate models and AI. And increasingly in your slides, and a lot of things I think, we now see AI not only driving the experimental loops, but the simulation loops as well. So in the long run, I mean, I would guess, I suspect you feel the same, but do you think we're going to drive more traditional HPC simulation workload from having AI than we had before?
Well, just like Manish said, there's always a hype curve, right? First, people say this will change the world, replace everything, and things will go down. But there'll be sufficient research engineering that we've done that will actually, restore the upswing. And I think we are, right now, programming, live coding is going a little bit. There was a big hype. In fact, the companies laid off a lot of engineers. Now they're regretting it because it turns out that some of the coding, humans are still indispensable. But now they're finding, on one hand, AI is getting even better, right, at coding, like the latest ChatGPT 5.3 or Claude 4.6 or the recent Qwen 3.5. So it's getting better, but also this synergy between where humans are good at and where AI is good at are being much more clarified to the extent that, it's growth in both. And there will be slow replacement because now there's a true productivity, and then there'll be slow replacement of the tasks. Yeah, so I think programming is here, for example, but it'll certainly be on the upswing, and so will science.